Hello everyone, my name is James Brown and I work here at PreziPoint. As you may know, the M8 has three different modes: the instant scan mode, the slide scan mode, and the live view mode. Today I will show you the instant scan mode. Now before we get technical, I want to tell you exactly what it is. This mode gives you a large field of view of a digital scan, but with the speed of a microscope. The instant scan provides you unparalleled, quick, and detailed overview of the whole sample. This can also make complete scans obsolete and is also well suited to identify regions of interest for later digitization in the slide scan mode. So for example, accessing a 15 by 15 millimeter area within seconds at high resolution allows you to perform analysis, looking for rare events, make your annotations or taking notes, and then of course, digitizing everything. Let's start from the beginning. First, I will start by placing one or two samples under the microscope to start the analysis process. This is normally the only interaction between you and the microscope. After that, all your work will be done using a computer.
We will now head over and take a look at the operating data. Once you start MicroPoint, you will be asked to choose a mode. Go ahead and click Instant Scan Mode, then Continue. The first thing that is going to happen is the M8 will generate two images. The one in the upper left corner is the overview image. The other is the viewport, where the examination and analysis will take place. There are several ways to navigate throughout the sample. If you take a look at the bottom right, the plus and minus buttons are there to help you zoom in and out of the sample. So if I click the plus icon, it will zoom in. Let's go ahead and zoom in a little bit more. Notice the red box on the overview image. It shows you where we are zooming in and out. Alternatively, you can select the magnification from the numbers on the bottom, starting with 5x and going to 100x. And I'll click all of them now so you can see the predefined options. Lastly, if you have a mouse, you can use the scroll wheel to zoom in and out of the sample seamlessly. Now if we click the one-to-one icon right there, the middle working area will enlarge to a maximum objective magnification. This all depends on the objective you have in the M8. For example, when you are working with a 20x objective, the zoom will be automatically set to 20x when pressing the one-to-one button. The icon next to it basically shows the whole scan. Boom, pretty simple so far. By dynamically navigating through the sample, you get the impression of a whole slide, which is not possible for analog microscopes. When I begin to navigate and zoom into the sample, you may find that the sample is not as sharp as it could be, and in some cases, it is just completely blurry.
To fix that, all we need to do is find the right focus plane. And with the M8, it is relatively easy to find. When you're using a traditional microscope, it can be difficult to find the focus plane. It can take several minutes to find it, and then you might need to find it again because the sample is so uneven, which makes it a long and tedious process.
To save valuable time, all I must do is zoom into the sample and click on the autofocus button, which will automatically find the focus plane for me. As we all know, not all samples are perfectly flat. So as you move throughout the sample, and you will find a section where you are out of focus again, all you have to do is just click that autofocus button again.
A quick tip before we go on. Autofocus on the desired sample and locate a spot with no sample in the vicinity. It must be white with no details such as dust.
Okay, so there's no dust. Click the IC button and we get this message. And the area is marked like that. A small note, make sure that there's no content inside the red rectangle, like these. Just move to another area and click OK, and the illumination correction is done. When a dialog box appears with a yes or no, you can see the illumination correction. Check if any patterns are visible. If so, press no and retry the illumination correction on another region. This one looks pretty good, so I'll click yes. There are two possible error messages that may come up. Let me quickly create those and I'll be right back. So I put them side by side. What happens is that the camera image brightness may be too low or too high, and then you'll have to redo the process. I'll go ahead and dismiss the too bright error box, and we can work with the too low. Dismiss that too, and then we will redo the process by clicking the IC icon. Then manually adjust the exposure until it is a light gray color.
The illumination correction is necessary to equalize the images for a seamlessly stitched scan, as the image itself can have a brightness gradient along the width and height. The brightness of every pixel is the same, and no tile patterns are visible anymore. Plus, the illumination correction is compensating color cast, so every pixel of a background image is dragged to white. Pro tip: make sure that the sample is not too far out of focus, somewhere between 70 and 100 micrometers.
With the use of the focus plane button, you will be able to set the current Z-axis position as the new focus plane. When you click on the Set New Focus Plane button, a dialog window will pop up to ensure that action. Here we will show a standard case where the sample is out of focus and the autofocus is not able to catch the focused images since the focus plane is set too far away. As you can see, the sample is out of focus and the object is too far away to focus on any material. We need to set the focus plane closer to the sample. To do this, we need to go into live view mode. Depending on how far away from the sample you are, you must either use the Find drive or the Course drive. When you have reached an image in focus, save the focus plane by clicking the Focus Plane button, or the FP button. Confirm in the next window. If the microscope is not moving down anymore, save the focus plane to move down further. Repeat this until you reach an image in focus. Here is another example where the microscope isn't moving down the Z-axis and the image is too blurry. I then set the focus plane even though the image is still blurry. I continue with the Course drive and repeat the entire process until I reach a clearer image. Notice how I did that a couple times. Now, that looks pretty good, so I'll set the focus plane one final time.
Now to the interesting stuff. Here's what makes instant scan mode so special. When we are navigating throughout the sample, the M8 is continuously scanning and caching images, but you can go live as well.
With one click, you can activate the live tile. Basically, you can see a scanned image live. Live tile creates a dynamic image with more accuracy where you can navigate through the different focus planes by scrolling up and down the Find drive bar on the right side. This is particularly good because now you do not have to rely on a scanned image, which may need to be rescanned. This also serves as a manual focus, which if you're not used to the feeling of autofocus, is much faster. You simply locate the focus plane and then again press the live tile button and the scan will update. The M8 in the instant scan mode gives you a much larger field of view and the convenience of live microscopy without having to wait for a scan. Areas can be marked, annotated, measured, and counted. And of course, all annotations can be saved and exported onto the hard drive in a CSV file format. So if you click the Annotate button on the right, you can start annotating in instant scan mode. Those are the options in the toolbar on the right. I'll click Marker Annotation and drag all the way until I've reached my desired endpoint. I'll go ahead and rename this Test 1. Next is the line annotation. Once again, click and drag until I've reached my desired endpoint. I'll rename it Test 2. Same procedure is for the polyline. That's the circle, the polygon, and the counting tool. With the counting tool, you must first outline your area of interest. Then you have the possibility to once again rename the specimens. After that, just click what you want to count and then you're done. And you can always either hide, unhide, delete, undo, restore, or even select the annotations that you have made. This play button will show you the selected annotation in its center. Click and drag it anywhere to the viewport. We can always hide, unhide, and delete individual annotations. Once you have made all your annotations, you can export them all as a CSV file. We'll click the Export CSV and a File Explorer opens. Just define a name and where you would like to save the file, and then Save. Annotations are a widespread need for many users. Traditionally, it is only possible to make digital annotations in scans or snapshots in the frame of view. With instant scan mode, it is possible to make annotations the same way you would annotate on a scan, but live, which makes the statistic output easier.
This tutorial has been a bit technical, and we know that there may be questions. Please leave a comment or contact us through our social media. We'll have everything linked in the description. Like and subscribe for more content, and we'll see you next time. Bye, everyone.